All right, folks. Welcome, everyone. Good evening, good day, good night, whatever you have right now. Maybe good morning for folks who are UTC plus infinity. Whatever. It's UTC plus 1 in our time, so it's 8:33 p.m. at the moment. Welcome, everyone. So yeah, for those who are new, these streams called Casual LeetCode are designed for me to solve the LeetCode questions under the pressure of being watched by viewers, and you can solve the problems with me. For you, it means you can see how exactly the problem should be approached during the real interview, as we have kind of proved that I've passed a bunch of them for Microsoft, Snowflake, and Google some time ago, so probably I know how it should be done. And you will see that, these nice stats, they don't actually guarantee anything, and I still can be stuck with some medium and sometimes even easy problem with follow-up or something like that. So that's totally fine. You will also learn how to overcome and what do you do when you're stuck with the problem and how you learn from that. So this is kind of the purpose for you. You can also solve the problems along with me. So that would be amazing. So I might be asking some questions before I go straight and start implementing, so you can share the ideas of implementations and stuff like that. So what we are doing lists, as I advised many times in my articles and videos. We are always doing lists. We don't do this daily LeetCode challenge bullshit questions because they're mostly useless and they don't have any pattern inside. So this one list I was solving before Microsoft and got offer, before Snowflake and Google and got offer, and we're gonna be solving it here again. I don't know what about offer, so yeah, we're still gonna be solving. So the approach is I'm taking one problem from each pattern. First, we're gonna solve all medium and easy problems, and then if we have some time in the end, we are going to solve hard problems as well. So we have solved 11 problems so far. I think the target for me should be something like 6 to 7 problems each stream. So that's how we are going to proceed right now. But before that, as I promised in my Telegram channel, by the way, Telegram channel, please do subscribe to this Telegram channel because we are doing polls. For example, today we were doing a polls to choose which new avatar I should pick as a, I don't know, GitHub avatar, Telegram channel avatar, blog avatar, everything avatar essentially. So your vote is extremely valuable for me, and you can actually affect the things. Sometimes we are voting about what should be the next topic for the article or for video, or what system design topic we should solve or something like that. So cool. I wanted to speak about keyboard layout a bit because I'm a bit fan of speed typing, blind typing, and also I ex-StarCraft player, Diamond League, by the way. So I like everything about my keyboards, and I like everything about nice, convenient, and good-looking typing, because this is kind of most big, not the biggest, but kind of substantial part of my job, right? So here we go. We actually do have, let me bring the editor here. So you can see probably right now you should be able to see the Visual Studio Code or whatever, right? I hope the scale is okay for you. If I struggle with LeetCode, should I start from Code Wars or Grind like top 100, liked top 75, etc.? No, start with LeetCode. LeetCode is already pretty easy. It's not Code Forces, right? So for Code Forces, I would not suggest to do Code Forces for any people that don't actually want to go hedge fund or competitive programming. You don't actually need that. LeetCode is pretty enough for getting up to senior role in average funk company. Just start doing easy. Actually, I would show you the article. So, oh no, I think this is the article. Yeah, so go here, find this article and read through it, how you should approach your problems. You will find quite a lot of useful things and tips. Yeah, I know that Code Wars and Code Forces are two different things, I understand, but still Code Wars are probably easier or maybe the same as LeetCode, but LeetCode is already easy enough for you to start. Just start with easy and medium problems, don't do hards. Now, back to the keyboard. So how I was evolving. When I was just learning English, when I was like 10 or 8 or whatever, I was typing like this, literally with my, where am I? Can I see myself? Literally with like single fingers, like that. Then I started using multiple fingers, but I was watching my keyboard every single time, of course, and this is extremely annoying, especially when you need to type something or kind of copy-paste in a sense from book to PC or whatever. So at some point, I think it was 2018, 2019, I've met one guy in my first company when we just passed the boot camp and then start working as a junior slash trainee or interns, whatever. This guy was a blind typer, which means he never looked at the screen at all. So he was like literally checking the screen and watching the screen, looking at the screen, and not looking at the keyboard. And I was like, wow, this is crazy. And he was able to beat me in this speed typing online or whatever. And I was like, yeah, I want to be like that. It looks cool. It looks nice, so I want to be like that as well. So then I learned a blind typing, essentially. So I don't have to even look into my keyboard whenever I'm typing, and we can do this test quickly right now to test the speed typing before I go further. Okay, so it's 300. At my best time, when I was practicing that, I was 500. On average, if I kind of do 2-3 more trials, it'll be something like 400. So this increases your speed typing a lot. But what I was saying, yeah. But then I got another problem. So this is kind of prerequisite knowledge for you to understand why we end up with Vim and with Vim motion. So other problem would be that you might have some piece of code. Let's even get something from our daily LeetCode challenge. Let's say you have this piece of code, and usually it was always the case that you are typing something, and then you want to move somewhere like here and edit it after the bracket in max. So typical way how you are doing that is either you type in, I don't know, I type something here, let's say, and then I go with my right hand from my J convenient button, which is this one, you can see it. I move this hand to arrows and start using my arrows, and then I need to move my right hand back to J, which is this blind movement. It's not the fastest possible way. Then I can type something, and then let's say I need to change max to min. Then I move it again. Then I'm changing it, and this like right hand, it's always like on my keyboard, and then it's either on the arrows or on my mouse, because sometimes if it's too long, right, I wouldn't use arrows. I would just use my mouse, click, and then maybe adjust with arrows or home end, whatever, and then I will type. So I got extremely irritated by that at some point. So what I decided, I've heard that there is Vim. What is Vim and what is Vim Motions? Vim is old, that editor that you have on your console. So I think if I go my WSL in Windows, right here, let's create some folder and then go to this folder. And then let's touch some file, txt, whatever. And then if you go vim file txt, this is the kind of basic initial editor that was created by clever people for clever people. I mean, it's not cleverness, but it's extremely convenient. So what is the purpose and what is the idea behind Vim? The idea behind Vim that if you're a blind typer, usually you have your F and J button, these two, there for your, I don't know how this finger is named in English, but you got the idea, this finger. So there on J and F, and you can blindly approach or get to any button you want to. And Vim has 3 modes, like it's a bit hard to learn, so right now I'm in visual mode, probably. So if I want to type something, I need to go to insert mode, type something, right? And then I exit this mode, and now I can, using my JKHL, I can essentially navigate with my caret without actually disturbing my right hand to mouse or to arrows, which was extremely convenient to me. And at some point, I installed Vim motions to my all editors, including Visual Studio Code, Rider, Visual Studio, everything. And it was kind of okay, apart from the part that, for example, on LeetCode, I cannot install my Vim motions on the browser, right? So if I try to do this, it will just type the letters. However, what I wanted Vim motions because this is extremely convenient way of kind of going around with the things. And I was pretty happy with the fact I don't need to move my right hand all the time to mouse or to arrows. So what I designed, I was looking for solutions, and I was looking for something that I don't have to install Vim motions to anything that I touch in my operating system, and I wanted something cross-platform. I found the solution. So solution is called, if you go to my Gist account, you can probably find it. So the solution for Mac OS is Carabiner. For Windows, it's how it's called. It's AutoHotkey. Yeah, AutoHotkey. So these are kind of the configuration files that I'm using, and they are essentially making Vim motions globally for your OS system. What it means and how I configured it. So for sure, I want to move still with my HJKL, as in Vim motions typically. So what I did, usually I don't use caps lock, so my caps lock is unusable, and I made it kind of as a visual mode. So whenever I press and hold caps lock, and I'm moving with this default buttons, you can see on my keyboard probably that it works exactly like Vim. So E means hello, hello. Lukasz, hello. Yeah, thank you, thank you. Yeah, now we are discussing Vim motions in why we need them and how I configured it. Because I think it's pretty cool. I never seen anybody else doing that. So for example, in Vim motions, H is going 1 to the left, L is going 1 to the right, K is going 1 to the up and to top, sorry, and J is going 1 to bottom. If you want to move by word, same thing that you would do with control or option actually, an arrow like this. For Vim, it's E and V back. Correspondingly, if you want home and end, unfortunately it's not displayed in my keyboard UI. If you want home and end, which should be exactly on top of your upper arrow, for that you have kind of dollar sign, which is usually in Vim, but for me it's just caps +4. And you have also lower dash. So these are you going home and end, and with all of these you can navigate pretty much fast and to closer distances in a sense. Of course, it's very limited. Usually in Vim motions you want to use much advanced kind of keys and much advanced kind of codes that can do and can make your life much easier. But for me, the most important part was that whenever I'm typing something, it's happening so frequently that I'm typing something and then I need to move back and I need to move my right hand to arrow and click it, and I got tired of that. And now, whenever I'm typing something, for example, I want to do maximum, maximum, and I tapped and let's say, I don't know, I want to change maximum to minimum. I can do just this, and it's pretty fast to move this caret, and I'm so happy that I created it. I now got used to it because I'm using it for like 3 months already, like this setup. It works amazingly. Then for highlighting, there is another Vim mode for highlighting, which is, where is my VSL or WSL? So whatever. In Vim, you have 3 modes, essentially. Visual mode, which is just going and moving your caret or cursor between the words and text and stuff. Second one is insert mode, is the mode when you're just typing and nothing else, you don't navigate. And there is visual insert, and there is highlight mode, or whatever it's called. So highlight mode is exactly like visual mode or regular mode or default mode, but it also highlights the stuff. So let's say I want to go from beginning to the end of the string. This is the default mode, I'm doing that. But if I want to highlight this, then I would go to visual mode or highlight mode, whatever, in Vim, and I would do exactly the same, but it will keep text that I'm crossing highlighted. So this is also the thing that is implemented with these scripts. They have the modes, so you can see that it states visual mode here. And I can go to this mode with caps and V and end this mode as well. So if I want, for example, to highlight something using this thing, I can, or like my script, I can use the following. I can use caps, shift, and then just move this thing around. It will work, but it's kind of cumbersome and not convenient. So apart from that, instead of this, what I would do highlight mode, and then this, and it keeps highlighting. Then I Control-C, end the mode, and then I'm going around again with my stuff, right? So this is something that I wanted to discuss. I probably will record video about that, because I think this like makes my life so less irritated in some sense, because I got so tired of moving my right hand from the J button to mouse or to arrows. Now at least I don't have to do it for arrows. So hopefully maybe some of you can use this. This is open source, so I mean you can just go, it's public. You install Carabiner or AE AutoHotkey. You copy this script and it just works. So just up to you. I will leave this keyboard because I think maybe it's a bit more interesting for you. Something like, I don't know, this brain rot Minecraft videos that are going on and people just got involved or engaged with them, whatever. Now, cool that we discussed this thing. I promised it on my stream, so yeah, this one we sorted out, and let's proceed with the essentially our list. So goal is 6 to 7 problems. Let's see where we stopped last time. So longest your sliding window, yeah. Now it's stack. You rejected Google offer, but then you said you want to work in Google in Dublin. Yes. Something changed? No, I wanted to work at Google since I was 20. The thing is that before that I didn't have enough skill. After that I actually applied for junior position and was thinking that software engineer 2 is middle position, but in Google software engineer 2 is not middle, it's junior position, L3. Yeah, and overall at some point I hope I will get to Google someday, some year, but we are going to stream from the Google office once. Yeah, I think this will happen at some point. Which point, I don't know. Okay, how many people are watching us? 10 people. Exactly usual amount of viewers, which is expected. Not everyone is was born for LeetCode. Anyway, let's start. So our first problem is a valid parenthesis. I maybe can do, can I do this? I just need a bit of a space. Whatever. So valid parenthesis. We are given string containing just characters, open bracket, open curly bracket, and open, I don't even know how this bracket is called, to be honest, in English. So determine if the input string is valid. Open brackets must be closed by the same type of brackets. Open brackets must be closed in the correct order. Every closed bracket has a corresponding open bracket of the same type. Okay. I remember like last year or something like that, I was solving that problem and it seems trivial initially, then you try to run it and you fail some edge case. Let's think through it. So this is trivial case. This is kind of trivial case. Okay, so this is not valid. All right, this is valid, and this is not valid. So I think this is kind of the corner case that we should be cautious about in some sense. By the way, do you see the screen all right? Should I do it this way? Like, can you see everything, folks? I hope. So this is the kind of case that we should be careful about. And so low acceptance rate, okay. So how can we approach this problem? So apparently, since we have many different types of brackets, we cannot just use same counter for them, right? Or try to count them somehow. And we cannot use counter also for the reason of this case. So let's say, let's even assume we are using 3 counters. So default bracket, then we would have, I don't know, square bracket, I would just name it like that. And we have curly bracket. Oh, we don't need bracket actually. So if we add counting here, so let me add the indices as well. So the default one, it's index 0, then we would have one squared one, then we would have closing default one, so it will make it 0. Then we will have closing square one. So we can kind of assume, we might have assumed that if we have this case, or if we have this case, in the end, some of these numbers will not be 0. And this can be kind of validation criteria or correctness criteria. If all of them are 0, we would be kind of, we have validated it and they are correctly positioned. But it's not the case for this specific example. So how we should do that? Probably, I think you all seen that this is the pattern of stack. So we should use some sort of stack. In our case, I think we will just use simple array or list, whatever. How we can approach that? We know that closing bracket cancels out any open bracket. And we know that in the end, if we resolve the brackets, so let's say this case, we know that if we start putting our, or pushing to our stack like this, in the end, once we meet the square bracket, we know that it cancels out the square bracket that we just got. So next time we resolve the square bracket, we will see default one, and we will see the default one cancel out the opened default one, right? So essentially what we can do, we can keep our array, keep appending the open brackets. Once it's closing bracket, we should make sure it is getting cancelled with opening bracket of the same type. If it's not the case, we are kind of, the input is not valid. If in the end we are left with some of the open brackets, it means it's also not valid because all the brackets should cancel out in the end. Kind of hopefully it makes sense. How it would look like, we are going to iterate by, we don't even need to iterate by index, we can iterate by character. So if it's open bracket, we just append it to stack and continue. If this is closed bracket, we check 2 things. First of all, our stack is not empty. If it's empty, it's not valid. Second thing, in the end of the stack, so meaning what will be returned by pop function. It should be the open bracket of the same type. This is what we are going to kind of check. So for checking that the type that we expect is the same, so like curly bracket should expect to have a curly opening bracket, we can kind of use the simple map or something like that. So it should be how. Okay, I would do this one, but I will need to Google how should be the data type for character in Python. How is it? I know that string is str, integer is this one, but what is the character? Maybe this one. Maybe it's a function. I don't know. Whatever. So what we're gonna do is we're gonna do this. So for closing default bracket, we kind of expect the value that should be on top is opening default bracket. And the same happens with this one. So we have this guy. And the same happens with this one. Yes. So these are kind of our expected values. Now we go with our stack. Bracket in S. So now if bracket in, if it's any opened one, then we blindly append it and continue working on that. Oh my god. If it's not, or rather than continue, maybe we can do this just else. Otherwise, if it's closed one, we should again check two types, or two things. If our length of stack is 0, we just return false, because it means we have more closing brackets than opened one. Then, if stack last element on the stack that we just appended, if it's not equal to map of our closing bracket, so if the end value on the stack is not the opening bracket of the right value, we just return false. And in the end, we just return length of our stack equals 0. Yeah, kind of for me makes sense. Let's try to run it. Well, it makes sense, but it doesn't work. We don't pop anything. I don't even need to look. Because if it does match, what we should do, we should pop the stack. This is what I forgot. Hey, I green for Amazon interview right now too, lol. Amazing. So yeah, join us. We are on top 100 like questions. Try to solve it faster than me being explaining these questions. And I hope you're going to be faster. So yeah, now we forgot to pop it. Now it works. Let's submit. Amazing. Move forward because we have 6 more left. Container with the most water. Okay, 2 pointers. I remember first time when I saw this problem, it was 2020 or something, I guess. I'm sorry, I need to do this. Yeah, 2020, I remember I was struggling so much with this problem, like hugely. But in the end, it was solved. Okay, so let's read through this problem. We are given an integer array height of length n. There is n vertical lines drawn sides at 2 and points of ith line are I0, blah, blah, blah. Find two lines that together with x-axis form a container such that container contains the most water. I've solved it too, but I solved after trapping rainwater. Oh, trapping rainwater is hard one, as far as I remember. Right? Yes, it's hard one. I solved it as well, but I don't remember how. I don't even remember what was the pattern for that, but whatever. Yeah, it's a nice problem. By the way, you see, I solved it, and let me actually check when. 1 year ago. Of course, I struggled a lot 5 years ago with this problem. You see, yeah, struggles were like for a couple of days. This was my way of solving problem, which was incorrect. But in the end, I don't actually remember anything about this problem. I don't remember like the approach and stuff. So don't ever tell your interviewers that you have solved some problem, because you will just raise your expectation of interviewer, but you still, like, the fact that you solved it before does not actually help, especially if you are solving a lot of problems. So get back to our problem. Maximum amount of water a container can store. So there is a kind of greedy intuition in this problem. So I would say this problem is also, it's not as two pointers problem as it is greedy problem, because you have to understand the right intuition to solve it. But once you understand it, it's kind of pretty trivial, right? So yeah. What is the intuition behind that? The intuition behind that, like, apparently we can just try out all possible combinations, but you see we have 10 to the power of 5. It means we are allowed to have O of n or O of n times log n, but not quadratic one. So it won't work, apparently. So let's think how we can do it linear time. Oh, sorry. Yeah, we go here. Go here. So amazing. Let's try. We kind of want to try out everything, so we want to start as far as possible. So these are going to be our 2 pointers, and the intuition is pretty easy in this case. So we see that our left one is 1, our right one is what? It's 7. This one is 1, this one is 7. Now, what it makes sense for us to move at this moment? Like, let's try out all possible combinations. So we can move this guy to the left. So we can move right closer to the middle. In this case, what we are winning? We are anyway are going to be capped by 1, because we are always capped by minimum 1, by minimum out of 2 these piles or whatever it is. What is this? Is it lines? Yeah, so we will be capped by minimum value out of these two lines, right? So if we decide to move the right one to the left, we are not winning anything. We cannot go better than 1. So the intuition here that we always want to move to the middle, the line that has least height. In this case, if we are at 7 and another one is 1, if we move here to the right, we can either lose, so it can be just 0. It's possible, but then we already have kind of 1, which was bigger. Or we can get anything more than 1. It can be even 2. So let's say these 2 does not exist. These 2 lines, they do not exist. So let's say we are moving to this pile. It's already 2, and now we have chance to reach the bigger amount. We have a chance to trap bigger amount of water, right? So intuition is pretty simple. We are always moving towards the middle, the line that has the least height, and this is kind of the intuition behind this problem. And once you understand this, this becomes pretty easy. So Let's start like this. Why does it work? Because of this greedy intuition. So let's try it again. If we have these pointers, this is 7, this is 1. If we move right one, what we can win? Like, can it be better? Can we then reach anything better than size 1? No, because we would lose this this compartment or whatever, this column, and we can win only, like, we cannot win anything. So it cannot be more than 1. So it will be just, always worse than if we try to move the shorter one. And in this case, we have chance and better probability that this is gonna be higher, and we can trap more water because we're capped by minimum. I know it's hard. First time I seen this problem, I wasn't able to solve this, so that's totally fine. So Solaris has solved this problem. Amazing, amazing, man. Let me catch up with you. So we keep our invariant. Left is less than right. Then what we are doing? We are keeping maximum area. And our area is going to be what? So width is going to be right minus left plus 1. Is it the case? Let me check. So indices wise, it will be this one. So if you're 8 minus 0 equals 8. Or let me try even with this example. So they have with 1. So we're gonna just check. It's going to be 7. Right, 8 minus 1 is going to be 7, and this guy 7. So 7 times 7, 49. Exactly right. So it seems like we don't need plus 1 here. Yes, we don't need. So this is how I empirically check whether I need plus 1 or no. So this is width, and height is going to be minimum of either of them. And then area is going to be maximum area width times height. And then, of course, after each of them, we're going to check if height left is less than or equal. If they are equal, it doesn't matter which one to move, I guess. Yes. So if left less than or equal, then we are moving left one. Else we are moving right one. And then we return area. Let me quickly debug in my mind. So we have left, right, and then, okay, we start width and height. So we start, our right minus left is going to be, oh my god, I need also to add, so it's easier to calculate. So our width, also this is the bug. Our width is going to be right minus left, which is 8 minus 0 is 8. Our height is going to be minimum one of them, which is 1. Yes. And then maximum area is going to be either 0 or 1 times 8 is going to be 8. Since height left is less than or equal than right, we are moving left forward. Now we have 8 and 7, which makes us what? 8 minus 1 is going to be 7. Height is going to be minimum one of them, which is 7. So it's going to be 49. This is our result, by the way. But let's see how it goes later. So we are moving the lower one, which is going to be right, because right is going to be less than or equal height, or just strictly less than height. Oh, so strictly less than left, sorry, because 7 is strictly less than 8, lower, smaller than. Oh my god, what's wrong with my English in the evening? It's terrible. So we're moving this one. Now we are at 3 and 8. Of course, we won't get anything better, because now it's 7 minus 1, 6, and capped by 3. 6 times 3 is going to be 18, which is less than 49. So yeah, we are moving this one here. It's 8 right now as a height. And we have 6 minus 1 equals 5. So it will be 40. But 40 is less than 49, so we skip. But now, look up, it's equal. So we are going to move left, 1. Now it's 8, 6. Yeah, and it will be anything better here. So I think it should work, essentially, I guess. So let's try it out. I'm sorry. We overridden the variable. Yeah, I think this should be the. Yeah, works. Let's try to submit. Amazing, works. Hopefully it makes sense. I think without this intuition, I would have an n log n solution with binary search plus suffix max, and another run with binary search plus prefix max. Can be, yes, can be. Can I explain when to use r minus l plus 1 and r minus l? I'm having trouble with off by 1 mistakes on my interviews. Yeah, it's typical one. So whenever you have indices, like right minus left, and you need to see the distance between the right and left. Like which one you choose. You have seen this one, typically, but in this case, you see that this is not the case. We need only right minus left. How do you do that? How am I doing that usually? I'm just running empirical example. So in this case, it's pretty trivial. I get this number, and I empirically check the indices, expected value, and what I will get out of my formula. So if I put right, left here, and right here, it will be 8 minus 1 is 7. So it got to be 7, because this is kind of how we get the answer. So this way, I for sure know it should be not this. I mean, if I put this, it won't work. So my way is doing it empirically, because if you're just doing it by, I don't know, by knowing or by remembering, you might just miss something, and then you will fail your interview. Or yeah, there is a guy from Twitch who actually explained it. Yeah, thanks. Another explanation, which is more formal one, is r minus l plus 1. It's both bounds. R minus L only one bound. And R minus L minus 1 is both of them are excluded. Let's go to the next problem, because we are kind of running out of time. MISC. MISC I don't like. I don't like the MISC. I don't like it. Is it the last topic? Yeah, the problem with this list, we don't have monotonic stack, which is pity. But maybe we will get some problem with top 150. Okay, next permutation. Array of integers arranged with its members into a sequence or linear order. For example, The following are all permutations of array. I already don't like this problem. I remember I was struggling with that. Yeah, of course. You see the pain. You see the pain here, guys, right? You see it. Again, 1 year ago I have solved it, but I have no clue how did I do that. So it doesn't make any sense to memorize it. However, our input is pretty low, so probably it's not linear. The solution is not linear here. No way we got the keyboard cam. Yeah, I think it's a bit more pleasant for you folks. A bit more exciting, I don't know. I didn't solve it. Looks like sort plus backtracking. Can be. The replacement must be in place and use only constant extra memory. So sorting does not help here. Let's see. So how do we do that? I think this can be the problem we're gonna stuck with. All right. Yeah, this is a huge problem, that replacement should be done in place. So for this guy, we need kinda constant extra memory. It should be 1, 3, 2. I already feel so many edge cases that can go wrong. So many of them. So it can cycle, sort of. Amazing. So this will be So we have this one. It means we would look for something. So for me, my basic intuition is that when you have this number, we will try it from right to left, and we will try to find the smaller number than this one, right? But I already see the problem with that is, what if we have smaller number, let's say here? What will be the permutation? So what I mean by that, the edge case when we don't find smaller number right away, but it's somewhere down. What should be the solution for that? So let's say we go from 3. Oh, no, sorry, this was not, because yeah, this is trivial one. I mean, this is just that one, right? What is other case we can have is this one. 1, 3 to 5, which is essentially larger than this one. So yeah, we need the next one. But what I meant, maybe, so let's do it by 1. So this is going to be 1 and this is going to be 4. Yeah, this is the case. What should be in this case the next permutation, right? It should be 2, 3, 41. So what it can be, because I don't know actually. 1, 2, 4, 1 it can be. Folks, we need to have constant extra memory. So bucket sort requires O(1), unless we want to reuse nums, which I'm not sure we can reuse, essentially. Maybe we can. Actually, it kind of tells you that we can. Whenever we have the values exactly the same as lengths, it means we can, right? Do we have duplicates? Okay. Let's try to use it without bucket sort. First, maybe bucket sort is the right solution, I don't know. Array of store values is, array of 100 values is constant. No, it's not. I mean, the thing is that 100 is the input. Whatever, like whenever your complexity will change depending on the input, it's not constant. So it's not considered as a constant. Okay, let me think about this. So this can be that one. We can have also, what else? We can have maybe 4, 3, 1. We can have 2, 1, 3, 4. And which one of those? This one is completely irrelevant, right? This is kind of the thing we want to have. It will be easier to reason about this without So yeah, it turns out that it should be this value. We can even check, right? We can add a test case. I'm really wondering what should be this case. And also I want some bigger test case, which is, let's put it that way. So 5, 6, 1, 2, 4. Yes. For now, let me return empty. I just want to see, to not miss what is the expected value that we should return. So I can reason about the solution based on kind of expected values. So for this guy, I should return, this one is expected, amazing. For this guy, I should return this guy. Okay, so it was 2, 3, 4, 1, and for this one it should be 5, 6. So now I'm a bit don't understand. But for 1, 2, 5, 3, let me copy from the chat. 1, 2, 5, 3, 1, 3, 2, 5. Yes. Yes, it's weird. Yeah, I got the less. You're right. Nice catch. Let's even add it here to the test case as well. So we are sure about this. You're right, because my solution is giving not larger, but smaller. Yes, you're right. Sorry, my bad. So this is essentially the trivial case. So how I can do here, we just go and we find We find smaller number and then we just swap. Yeah. And if the smaller value is somewhere down the road, which is this case, because in this case, first value, which is 5, is not the smallest. So we have to skip it and swap with next smaller value. Which, okay, let me do it separately. So let's assume our logic and intuition would be that we take the right number and we try to find the first smaller number than our right number and swap with that. Let's assume this is, let's just guess. I don't know. So it will be 3 and we swap it with 2. But this is not the answer, right? The answer is actually a bit more complicated one. So now as we swapped with 2 with 3, we now have to swap these 2 as well. And this, yeah, how do we know that? What if we have bigger one? So 2, 3, 6, 4. And let's assume here we have 5. What will be this case? I just want to know what is the expected one? So this is the expected one. What the hell? All right, so for this, if we try to apply our heuristics, so we find first smaller number, which is for 4 is 3. Let's assume we changed it. So 2, 4, and then we are left with 6, 5, 3. Let me change it to, yes. Now we're left with 6, 5, 3, and 6, 5, 3 should completely reverse. Is it the intuition we should follow? Yes, exactly. So look at this case. If our smaller number than 4 is here, it's probably guaranteed. No, it's not guaranteed. Oh my God, so complicated question. What if we have this one? Then what should be the answer? Because this one, okay. Maybe the logic is we swap with the smallest one, and then everything that happens to be after the smallest one, we just reverse completely. So we put 2, 4, and then 3, 5, 6. Here we go. What about this case? And during the interview, yeah, I would be discussing all of this and thinking. I wouldn't write a single line of code before I know that. This is how I should do it, unfortunately or fortunately. So 2, 3, 5, 6. I mean the case when we don't have strictly increasing, but still bigger than 4. This is bad. This is I don't like, because it completely does not apply to what we have. So instead of this, we can find the first smallest one and we change the values. And then if we just follow our logic as this, as here, it will be 2, 4, 3, 6, 5. which is kind of completely not what is happening. Okay, seems like I'm stuck at the moment. Salt, can I put a solution here? Try to put a link to your solution. I'm gonna check. But good that you solved. I still didn't solve. I try to catch the logic because now I even cannot understand manually what I would do manually, like hand by hand, and trying to put the characters on my own. I don't know what heuristics we should use here. So for this case, we don't even have to find the first lower than 4. Okay, so maybe we can try to work with a couple of numbers, because what I also see that if it's increasing, we kind of continue searching. But if it's going down a bit, so what I mean by that, if we represent our number as lines, so this thing, it will be 2, 4, 5, 6, 3. Oh, sorry, we need to represent different. Sorry, I failed it. So this number, sorry, it will be 2, 3, 5, 6, 4. This will be the kind of line of the number, and this line will be the. Let me draw it upstairs. It will be 2, 3, 6, 5, 4. Yeah. 2, 3, 6, 5, 4. So we're kind of looking for line that goes down, or what? What are we looking for? What we're looking for, probably yes, we are looking for this spike. And the first spike we found six, 3, 6, 5. Yeah, so we're kind of looking for first kind of difference in numbers that goes down, that is not growing, but goes down. Because it seems this is the pattern. So in this case, it will be 5, 6. In this case, it will be 6, 3. And then what we are doing, we are changing, we are swapping these two values, 4 with 5. So in this case, it should be 2, 3, 4, 6, 5. Okay. In this case, it will be 2, 4, 6, 5, 3. And now, in this case, we just, after we swapped, we reorder everything. And in this case, we do not reorder everything. We do not reorder everything. Oh my God. Why don't we? What is different about that? Can we solve it as a sub-problem? I'm running out of it. I will try 5 more minutes and then I will just look up for a solution. Can it be solved as a sub-problem? So for 4, 6, 5, what we should look for? God, it's even cognitively like painful to learn like what should be the expected result. And in this case, so I have gut feeling that it can be solved like that. Let's see. So what I'm looking for is I'm looking for solving kind of this, then no. Oh my God. No, apparently it cannot be solved as a sub-problem. Yeah, I ran out of idea. To be honest, yeah, I'm kind of stuck how to do it in memory. And no hints, thanks God. Okay, can I put a solution here? Yeah, you could put solution. I missed an edge case. Well, yes, this is the bad problem for interview, to be honest. How long are you grinding LeetCode? Quite a long, if this makes sense. 1 year I have 150 sold on LeetCode and then sold 100 plus in grokking the coding interview. I have no idea what it means, but whatever. But I mostly sold mediums plus hards. Good, amazing, nice, solid progress. It was for your question. Sorry, Nicholas, it was for your question. I missed it completely. Yeah, I missed completely. So let's check the discussion. I'm actually wondering what people are writing. Amazing, Facebook is asking this question. Facebook was asking that. Well, this says quite a lot. Let's try to get a hint. I don't know. Okay, this is our permutation, whatever. Understand the breakpoint. The breakpoint is a special spot in our number sequence that things start to get interesting. Yes. Right and move left. This we already concluded. First number that is smaller. This we already concluded. What do we do about like what's happening after? Small number is our breakpoint. Yes. Our breakpoint will be 1. Yes. Yes. But maybe our breaking point we want to swap with the least possible value we have seen so far. Ah, no, it will be already the case. Okay, whatever. 5, 4 part is already biggest. Yeah, makes sense. Okay, makes sense. Like up to this point, we get everything right. Up to this point. Okay. Okay. Yes. Well, reversing doesn't work here, right? Or does it? Come on. Like, what are you talking about? Reversing doesn't work here. So let's say in our case, let's just try it again. Oh my God, maybe I missed something, but reversing shouldn't work here. So let's say our kind of point, or how this guy called it, break point, whatever. The first digit less than 3 is, or sorry, less than 4 is 3. So we're swapping. This is the break point. Let's put it even here. Oh my God, no, I didn't want to do that. I wanted to do this separately. So, and then if we reverse everything that are left, or that is to the right, so it will be 3, 6, 5. Yeah, it doesn't work. Yeah, it doesn't work. This doesn't work, man. But this doesn't work, come on, this doesn't work. We just found a case that it doesn't work. Wait a moment. Okay, let's try again how you're looking for breakpoint, because I thought you're always considering the rightmost digit. Okay, so we get back to our intuition, which is this one. We should find first slope down. Either this one, in our case, or this one. Okay, then again, you're swapping with the least possible value. Okay, and you're reversing whatever is to the right. Okay. Let's try again. So we are 2, 3, 5, 6, 4. We find our first slope is this one, 5, 6. We reverse it. And our breakpoint is, what is this? Then we're reversing everything to the right. Oh my God. So it will be 5, 4. Sorry, 4, 5. Oh shit, okay, this guy is right. This guy is right. With the smallest, okay, let's try this. So he found the first slope, which is this one. 3 and 5 swapped. Smallest. Smallest larger number to its right. So once I find the breakpoint, I should run another loop. I mean, it will be constant. That's all right. When I will find the smallest larger number, and I will swap them. Let me run it again. I guess we got the algo. We got the algo, guys. We're soon. Sorry for that. Sorry for that. I will read comments in a bit. So let's move it again. I need even to. It's too hot here. So we find the first slope down, which is 5 to 3. We find smallest larger number than 3. 5 can be a candidate. 4 can be a candidate better than 5. Yes, 2 is less than 3, so we find 4. Okay. So we swap 3 and 4. Keeping in mind that breakpoint is 4 in our case. And now we need to reverse this guy, right? Everything that is to the right. So we're putting 2, 3, 5. Okay, I got the algo. So now checking the comments and then we're going to implement. Extremely hard question, guys, for me, to be honest. Extremely hard to build intuition. I don't think it's very hard to implement though. Hope you passed the interview. Thanks, man. I'm focusing on BFS, DFS right now. Pray for me, please. I don't want DP. DP is not that bad, Nicholas. It's not that bad. But good for you. What are you prepping for? Do you have some specific companies you are targeting? Meanwhile, if Nicholas is still with us, we are going to implement. So yeah, let's implement the stuff. Again, algo. Find first slope down. I mean by that the first number from right to the left that goes less than its right sibling. So 4, 5 growing, 5, 6 growing, 6, 3 decreasing. So first decreasing number, let's say. First decreasing number. Then we are going to find smallest largest number to the right. I assuming we can do it in not number, but actually index. We are interested in index. First is in number, also index. We will be using indices because with indices we can swap easier. So Nicholas has Amazon. Oh, actually you mentioned. Yeah, I forgot. Amazon have it on Wednesday. Wednesday is actually approaching. So Wednesday you mean tomorrow? Or no, the day after tomorrow. Okay, good luck, man. Yeah, Amazon for me it was one of the toughest interview experiences back then, which I didn't pass. They have pretty easy system design, but not LeetCode. I got into Google, the tasks were easy. I had a hard with the double queue and the door, so many edge cases. They gave me hard because I bragged that I solved KC, probably LC for 6 months. I don't know how I solved it though. So you got into Google, so you got offer. Tasks were easy, but you struggled with one problem, right? Because of edge cases. Good for you still. I think you can get in Amazon. Like, come on, no problem. Good luck, man. Good luck, man. And then reverse everything to the right after breakpoint. Okay, so this is how we're going to do. So our break B point. Let's name it B point. Mouse -1. Not offer team matching, bro. Well, this is essentially kind of almost offer. They close the pipeline. I'll send you the problem from the Google interview right now. Oh, sure, let's go. I wish we can solve it. Or you can send me at least privately. I can solve it later because, maybe I will need it. Who knows? So yeah, I got to team matching last year as well, but I had competing offer from Snowflake, so they found me team in 2 weeks. Try maybe to play this game. I think if you get offer from Amazon, you can press them quite a lot. But team matching phase, it means you actually passed the interview, so it is sort of offer. The thing is just they try to find your position. So kind of you can already consider that you get offer. Okay, so B point is this one, and while we're gonna have index which is nums -1, or index less than or equal or greater than or equal 0. Actually 1. We are doing right one, which is nums index, left one, which is nums index -1. Then we compare. If right is greater than left, I hope there are no duplicates. I hope that's the case. Then we found our breaking point, which is our left, and we break. That said, if our index is 0, it means we don't have any breakpoint. So it means we got this case, which we just reverse everything. So I think we need to write a function for reversing. Which is, just while left less than right. Nums. I think we can use this time this Python convenient function just to swap the stuff. This will be the reversing part. So in this case, we just reverse right. We reverse everything from 0 to len nums -1. Okay, so Snowflake is the GOAT. I love them. I will leave my Telegram. Or find me in my Telegram group. that you can find in the description on the stream. And if you have an offer from Snowflake, or you're considering Snowflake, yeah, let's talk. Yes. Here's the problem from the Google interview 25. Oh yeah, let me check. 2534 time taken to cross the door LeetCode. Fuck, okay. But I remember we have something LeetCode or whatever. I have to find it. Oh my god. Where is premium? LeetCode. We have LeetCode. I think they can have no Alco Master. I don't care. I need the problem itself. Can you please give it to me? Okay. Let's try to find it here. Okay, whatever. I will find it later. Thank you. Still, thank you for giving this. I will try to solve. I'll get this from premium because I never had premium in LeetCode, and that's okay. So if we got to the Algo monster, the Algo monster. Oh, really? And people number. Okay, I will check once we solve this next permutation thing. Thank you so much, by the way. Just return. If index is not equal to 0, it means we found the breakpoint, and then our fun logic starts. And our fun logic is that we are going to put yes, for I in breaking point plus 1 till the length of nums. We are trying to find I don't know, let's name it the best. And the best we want to get minimum, so we put infinity at first. Now what we are doing, we kind of have guaranteed there should be such number, so it will always, we will always find it. So now how do we approach it? So if nums b point is less than this I, we kind of do best minimum best nums I. For now I will do slight debugging for myself. We also need best index -1. Okay, if okay. B point, by the way, is index, so best one should be also index. Yes, B point. Yes, it's in. No, it's not index. Actually, it should be index. And what we are also missing is that index. Yes. Now that we find best and index, we need to swap them. So nums b point nums best index equals nums best index nums b point. And now we need to reverse everything that is after b point. So b point plus 1, length nums minus 1. Oh my god. Right. It's interesting. It's interesting. All right. Let's try to run it because we spent too much time. We still have a bunch of problems to solve. I don't think it will run. Probably it won't be running. Yes. This is the problem we have. Essentially, we can do this a bit less code, easier to understand. Well, so it's left. Okay. Okay. Essentially, to me, logically this makes more sense. Let's try to submit. You see this? You see this? Oh my god, yeah. I was very surprised that this kind of complicated code ran from the first shot. Let's try a bigger one. No, it didn't. Of course it didn't. Because we have duplicates. Duplicates I didn't account for. All right, so how it should work with duplicates? Somewhere here along the line we should put this thing. Let's try to run this in our mind. Yeah, these type of questions, I don't think they should be asked during the interview. It's extremely hard. It should be for staff or something, right? And it doesn't have any pattern, by the way. 2.3, amazing. Amazing. 2 pointers, thanks so much. Oh my god. Okay, let's see. So our breakpoint should be which one? First, lean down on our, or slope, or decrease is going to be this one. So we are going to have breakpoint is 2. Amazing. Then the least is going to be 3. But my problem that I was swapping with the first 3 probably, not with the last 3, right? I was swapping with the no, it's the last 3 actually I was swapping. Okay, but then we should reverse. Didn't we reverse? Let me get my debug back, please. Breakpoint is 2, 0, 1, 2, or 0, 1, 2. Best 3, 0, 1, 2, 3. Okay. Yes, yes, yes. This should fix probably, I hope. No, it didn't. Why? We just should go all the way to the right. Now it's correct. What can I say? I don't even know how to solve this. So we reversed. It's the case when breaking point and changed value is the same. What should we do in this case? I don't know. Let's check this guy again. It doesn't account for duplicates. Yes. Oh my God. So what we should do in this case? We have reversed, but reversing didn't change anything. So if we have the same, I'm wondering about the case, about such case like that. Then what should we do? Oh, sorry, initial one was 151. So I find this guy we reversed, we are at the same place. Oh my God. Yeah, sorry, it takes too much. I have to ask them help because this is crazy. I'm tired of thinking about this problem already. I just, it's too much. I think we're solving it for like 1 hour or even more. Amazing problem. Okay, so it says this should be not strict, then it will work. Let's first ensure it will work. Yes, it does work. But now, why this wasn't working? Okay, whatever. I'm tired thinking about this problem. But yeah, the thing is that it was not exclusive and somehow it's worked. Wait, so for this one, what we would have? First breaking point would be the left. We lost the music. So first breaking point would be where? The left one, which is this one. So breaking point would be apparently here. This is my assumption. Now we are finding from breaking point plus 1, we are finding nums i's that is bigger than, so we would find this as a best index and we would swap 1 and 5. Or what do we? Okay, so we were swapping 1 with 1 instead of 1 with 5. I got it. Makes sense. I only can't understand the edge case where we need to reverse everything. What exactly you can't understand about this edge case, man? Tell me. Why it is the case, or like why do we need to reverse, or how exactly we reverse? Like the thing is that, let me try to draw it on our numbers line. So these are numbers line, and we see the slope down in our edge cases, right? Oh, sorry, not edge cases. So breaking point is the first slope down. But if our number line is constantly growing, there will be never slope down, you know? So we kinda cannot find the breaking point. So in this case, this is explicitly set here, I guess. While an experimentation of array is 1 to 3, because 3 to 1 does not have lexicographical larger rearrangement. So it's kind of the edge case mentioned exactly in the description, that if we have this case, what we need to do that one, essentially. Hope it makes sense. Yes, exactly. Because breaking point, it's only on the slope down. Kind of like that. Okay, it was a good brain puzzle. I feel headache already. But we are not done yet. Well, we are. So this is MISC. Probably the shittiest problems are here. Let's go back, and we are with backtracking. So you remember backtracking, it's always exponential, so that's why we have low constraints. The easiest way to do that is doing, how it's called? A recursive call with single variable that is kind of current value, and then you just append current value in the end of the recursive call, essentially. So in this case, we need to generate all combinations of well-formed parentheses, which means like this is not accepted, this is not accepted, and also this is not accepted. Since we have only one type of parenthesis, I think how we can operate on that is for each state we can kind of track open and closed, or essentially we just need to track open ones. So our single counter is going to be maintain number of open if it makes sense. So we never want to go negative. And we never want to be left with something not 0. So initially, all parentheses should be equalized. And the way we would validate this case, because in this case we're going to get 0, we never should go less than 0. Whenever we put open bracket, we increase by 1. Whenever we put close one, we decrease by 1. And we try to put all of them equally. So our recursive function would be the following. We are going to maintain global variable current, which will represent just the array of parentheses, which we will then materialize as a string. Each recursive call, the end call would be when our n reached 3. So we're going to also kind of maintain probably second counter. So first one would be a parenthesis. Second one will be, I don't know, index. Let's name it index. Or no. No, we actually don't need index, probably. No, we either have to have open closed or this single counter and index. Okay, maybe going with two variables as open and closed. So this one, the number of open brackets and number of closed brackets. Maybe this one is easier. The invariant is exactly the same. We should always keep open more than or equal closed. And in the end, in order for us to know whether we can add it or no, open should be equal to closed. I think this one is better. So essentially, we will need 3 variables. One of them should be global. We have a recursive call with open and closed inside. Initially, they are equal to 0. Inside this recursive call, we decide whether we can add open in the case open is less than n given to us. But when do we terminate? Yeah, so if open is less than n, we can just add one branch for adding open and call subrecursive function. Or if open is already filled up, or even if it's not, we try to put closed. Closed is allowed to be put only if open is bigger than current close. And we call a recursive function on that branch. And then what else? That will be actually it. We actually should only put open or close. It was one of the first backtracking I solved. Yes. These are like, when you see 2-digit numbers in LeetCode, any experienced LeetCoder probably solved all of first questions probably. Let's actually check. I'm wondering which one I solved. So all easy meat probably are solved, you see. Okay, for sum is not solved somehow. Divide to integer is not solved. 20% of acceptance rate, well, it makes sense, it's not solved. But yeah, most of these 2-digit things are solved. All right. Yeah, I actually promised. Yeah, let's finish this one. It should be easy. So again, we are maintaining our current. We need response as an array of results. Then we have our recursive call. Let's name it just recursion or whatever. We have open, closed. If open equals and equals closed, then what we do, response, append, join, current, return. Otherwise, if open is less than n, then we spawn what exactly? We add in current append open one, we spawn a recursive call with open plus 1 closed the same, and then we call pop. Then if else, if closed less than open, right? Yes. Then we current append closed, calling recursive and calling current pop. Then we should call this one with 0, 0 and return resp ons. To me, this kind of should make sense. Let's try to kind of debug it in some sense, but debugging will be extremely hard because it's exponential, right? So let's just try to logically to go through ifs we have. So first thing, will we have an infinite loop or Stack Overflow? Well, open will always grow up until n. Then we'll have closed growing up until it's the same, and then we would end up. Seems like it will be working. Yeah, to me, it seems like it should work. It does. Amazing. Let's check quickly this problem. You have n people number from 0 to n minus 1. A single door can only be used by one person at a time. Each person takes exactly 1 second to pass through the door, either entering or exiting. Okay. You're given two arrays. Arrival, the time in second when person I arrives at the door. Okay. Okay. Oh my god, so long description. So isn't it greedy in a sense? I don't know. Answer I is the time when person I crosses the door. So arrival, only person 0 wants to enter. Okay, person 1 wants to exit. Person 2 wants to enter. Since someone entered at t equals 0, I would probably solve it offline because it seems like a bit tricky problem. But yeah, thanks so much. I will maybe review it next stream. Maybe I forgot about everything and got creative and solve it somehow. Yeah, probably you can get the right state. It sure makes sense. So let me solve one more problem. Yeah, we need at least two more actually. We need binary search, or I hate this, but we got to do it. Can integer num sorted in non-decreasing order find the starting and ending position of given target value? Okay. Yeah, I remember this is kind of bisect left and bisect right. Actually, I think we can solve it easier with Python magic, because I'm sorry, I don't want to parse this. Python, what is bisect left and bisect right logic, and how to call it. Yeah, this is one of the reasons you should use Python. Probably Interior won't accept it, but who cares? We can do just that. So we can just yeah, let's try this. I will just try bisect left nums target. Should be array, right? Set right nums target. I'm just wondering, will it work or no? In my opinion, should no. Okay, fuck it. Let's solve it a true way. So first thing what I'm thinking about it is that we can first maybe check that this target exists at all, right? And after that, we can kind of try to find the boundary. So yeah, this is my first kind of impression about this problem. Many people may have some people watching. Okay. So yeah, first thing we can, by binary search in log n, we can find whether target exists or no. If it does exist, then what we can do, we can try to search for, if we do binary search for number less than 8, right? Then we will find either 7 I just solved 2 with binary search, just with, okay. So what if we try to find one element less than 8? Let's try this. So how to find left boundary? Bisect left was working essentially. So it means that so it means if we go and try to search for the 8 with the right binary search approach, we can actually find it pretty fast. So our mid will be here. We see that target is bigger than we would have our left here. And then our mid will be here. And mid is less than or equal, or how we will, would we put equal to while or no? If it's less than, okay, let's first try if target is less than or equal mid. If we would use this logic, and then if it's true, so we would do what? Exactly, we will, if target less than mid, then we should put right. So right equals mid minus 1. Let's try to use this logic. Again, we're just doing empirically it. I don't know binary search well. I'm doing it empirically always. So in this case, what we will have, we would have this case, right? And then mid again will be the same, so we'll move right again here. So by returning left, return left pointer. Let's now try to find the right pointer. Again, let's see, we would have this case we'll end up with. How do we approach this? What if we do this? So if target less than meet, no, we would do, sorry, let me copy paste this. Then we would do target, is it less than meet? No. So we would do else. Oh my god, it's so painful to get these conditions. So we would do left equals meet plus 1, which is we would move here. And now let's even say this is how we would end up with, right? Yes. So now how do we know? Meet exactly the same, so target is less than meet. Yes. Target is less than meet. Then we move, right? Meet minus 1. So we just return right pointer. So these are two binary searches that I would run to get these targets. And what if target is not even in our... Yeah, I think we can run them, and then we can check that index is valid and if the index points to the actual target. Yeah, this is what I would do. So left pointer, let's move it to -1, whatever. And now we are applying our logic. If target less than num, is it nums? Yes, nums meet. Then we are doing right equals meet -1, else left equals meet plus 1. Sorry, let's do this one. And in the end, left pointer is going to be left. Amazing. We are going to redefine exactly the same thing. Then exactly same thing. But we're gonna use different piece of logic, which is this one that we just empirically proved it will work. And now right pointer equals right. Yes. And now what we are going to check, if left pointer more than or equal 0 and left pointer less than nums and nums left pointer target, then we return left pointer and right pointer. Otherwise, we return -1, -1, right? I hate binary search. Ah, sorry. Let me check at this basic stuff. Yeah, as I see the comments, or yeah, messages, I will answer in a bit. Yeah, it works. Will it get me time limit exceeded? It's log of n. Don't mess with me, LeetCode. It cannot get me time limit exceeded. Hello? Hello? Okay, meanwhile I will, yeah, it worked, amazing. So, just in the first one we do r-1 nums. Okay, I have my special binary search logic that is cognitively easier to understand to me personally, so sorry, I wouldn't be able to parse what you're saying. Can you explain why you find mid this way and not ml plus r? Yeah, this is actually, yeah, so we could do this one as you proposed, L plus R divided by 2, but it can go out of bound. So if it goes out of bound in some languages, you will get not out of memory, but you will get a garbage integer in the end. Because if, let's say, you have integer, in Python it's not the case, right? In Python you don't care. But you have integer type, and let's say you have two numbers that in the, yeah, of course you would do this one. I'm sorry. That by summing these two numbers you will get some number that is more than that. Then you will get garbage number in the end. But if with this approach you are not going to have L plus R, you are going to get much less numbers. So this way you are more safe against out of bound, especially. Oh yeah, according to interval. Yeah, exactly. You don't want to have overflow. And the last one, how many we solved? 16. Yeah, let's solve last one. This is binary search. Next one is binary tree. Yeah, trees. I like the trees, and especially graphs. Given the root of binary tree, determine if it's a valid binary search tree. Less subtree of a node contains only nodes with key strictly less than node's key, and right. Okay, I remember it was some min-max magic. Right subtree of a node contains only nodes with key strictly greater than node's key. Okay, makes sense. So the logic is the following: we should keep track of allowed key while we are traversing the binary search tree. What do I mean by that? Let me draw it a bit. So what I mean by that, so here we have 5, and everything here should be bigger than 5. Everything here should be less than 5. So for that, we can have a recursive call that keeps track of maximum allowed and minimum allowed. So for that subtree, probably we would have infinitely large, and minimum value should be 6. Oh fuck, this is false, yeah, because it's yeah, I was thinking, I'm like, why it can be 4? So let's put here, it should be 5, then this can be 4, right? This makes it, no, it doesn't. It cannot be 4, it should be 2. Yes, 2. So it should be then maximum of infinite, and minimum number should be 2 plus 1, which is 3. 5 does apply that. So here we would see that we would have infinitely large number and minimum is 6. And here we would have, well, now we should have maximum number as 4, because it should be less than 5. And this one we carry over. So this is how we work out. So essentially, we're going to create a recursive call, and with this recursive call, we are going to decide which is allowed value. And if the value is not allowed at some position, we're just going to return false. And if subcall return false, we just propagate false up to the call stack. I hated this problem more than anything. Took me 3 days to solve first time. You mean binary search or binary search 3? Just a request, is it possible for you to start series called LeetCode for Dummies, where you explain as if you are teaching folks who don't know anything about coding? Yes, I have plans for that. It can be done, yeah. But I'm not that skilled. Like all of this, where is my profile? All of this is just pure grind, Lineage 2 style. I don't have much confidence in myself with this one. I mean, I have basic patterns, but yeah, the BST problem. Okay, all right. So let's try to solve it. Let's see if I'm getting stuck or not. We have minimum and maximum. We're going to return Boolean. And of course, we need to track node. So if not node, so meaning there is nothing here, we just return true. Because by definition, if tree is empty, like we don't care. Then we are starting our interesting journey. So for the left one, we are going to do what? We're going to do the following. Is valid for node left. And again, for left, let's actually change it to my order, because for me it will be easier cognitively to check. But it makes sense to have minimum on the left side. Anyway, so when we go right, we keep maximum as we did already. So the one we have. And minimum is going to be maximum. Oh my God, I have a headache already. We should stop at this problem. So here we would have infinite tree. And when moving to the right, probably we want to have maximum, I would say. Right, so assume we are at 5 and we have maximum, we have minimum already set to what? To 3, right? And then here we are doing not value plus 1, which is 6, or minimum, which is 3. Make sense? If not is valid, we just return false straight away. And same we are going to do for the right node. But here I'm just guessing, because symmetrically, just by symmetry property of the tree and the nature and universe, it should be this. I'm just guessing. I'm just guessing, so let's check it out. So here we have node right, and we have value 5 and infinite. So it will be 4, yes. To me, kind of makes sense. And now what we want to check is initial one. So to the right, we're going to have infinite 3. So root right, we're going to have our maximum is infinite, and minimum as root value plus 1. right? I'm just I don't even think about this. I'm just empirically doing what I just thought about while I was doing brainstorming of the problem. I don't even think anymore. And for the left, it will be kind of the opposite, right? What it will be to the left? Let me think. So to the left, our maximum can be 1 and minimum can be minus infinite, no? Yes. So it will be maximum is root value minus 1 and minus infinity. Let's just check this. We have not value, we have val. Amazing. Something is off. It's the second case. Of course, because we are not checking anything. Oh my god, stupid. I'm stupid. We also should check whether if not value is less than or equal our minimum or not value is more than actually exclusively. Then maximum, then we return false. Oh my god, of course I didn't check the values themselves. Yeah. It was supposed to be let's try this example. This is the last problem for today, folks. I don't have any more energy. So let's say we're starting to the left as 2 minus infinity. To the right, we are starting as infinity, just I, and 4. Amazing. Now 5 so 5 will be not more than maximum, of course, because it's infinity, but 5 is not less than minimum. Also true, so it's good. Then we move to the left, and to the left we're going to have maximum, which is current maximum, which is infinite. No, it shouldn't be infinite. It shouldn't be infinite here. I guess it should be, yeah, 4. So maximum that we can have here is 4. And minimum that we can have is 4 as well. Probably same applies here. So let me try just symmetrically do the same thing. Wait. Wait, it doesn't make sense. I mean, let's just try. I don't have brain capacity anymore. No, it does not work like that. Fucking shit. You see, I stuck as well, but I don't have energy anymore. So let's try to debug that. This one got 4, which is minimum out of maximum and not minus. Okay. And right one will get no value minus 1 as a maximum, so 4. What? Should be plus 1. Should be 6. No, maximum should be still. Oh my god, I messed it up. Let's try to debug it again. And let's do it that way. Like proper min-max, because it's cognitively easier. Okay, we are starting from the root. We're starting from the root. And to the left, we take minus infinity 2, which makes sense. Here we take minimum as 4, maximum as infinity. Makes sense. And here to the left and to the right, what we are taking. This thing should be more than 5. So we should take minimum as 5 plus 1, so 6. And maximum still infinity. Here to the left, we should make it less than 5. So maximum can be 5. And minimum should be the same. So you just copy it, right? And here we just copy it. Let's see how it works here. So for I minus 1, to the left we just copy minimum, which is minus infinity, and get y minus 1 wait, this one should be less than 1, so we should take 1 as a maximum. Sorry, 0, because we are minusing, yes. And this should be 4 as well. I'm sorry, yes. And now this guy should be more than 1. So we are taking minimum as 1 plus 2, which is 2. And maximum, we just put here 2. Okay, so kinda I now got the idea. So some of them we cannot use minimum and maximum. So for the right pass, what I can see, we just leave maximum as it is. So for the right pass, I will leave maximum as it is. For the right pass, minimum should always be not value plus 1. So I put not value plus 1. Ah, fuck. not value plus 1. To the left, I can clearly see that going to the left leaves minimum as it is. So we leave minimum as it is, but we are always set maximum as not value minus 1. Let's see. I'm missing some of the maximum here. I'll just try out, but I'm sure I'm missing maximum or minimum function. So no, it works. I don't even need minimum or maximum as a function. It works. How did I do that? I just went extremely hard cognitively, processing every single step in my mind, and then having this mental model drawn, I just implemented precisely what I drawn on the picture in the code, and it worked. It's hard, it's time consuming, it's energy consuming. I'm very tired right now, but it works. Now, you need since boundaries are strict, traverse left maximum, yeah. Can you just pass root rather than comparing both left and right? Return is valid true infinite infinite. Can I do this? Well, let's try. Let's try it. Probably it might work. No, I will not pay you premium. Yes, it works, man. You're right. Yes, that's actually better logic than what I had. So, folks, it's done. We did how many? 6 problems, which we should do one more, but I'm too tired right now. I'm like veggie mode already. So thank you so much for being with me, folks. We have 6 people left in the end. So hopefully it was kind of interesting for you. Don't forget to subscribe on my Telegram channel. I will be still, emphasizing that, because here we have stream announcement. You can vote and affect what content will be on, and even choose picture for avatar, the future one. Yep. Don't forget to do that. And thanks for being with me, folks. I was really enjoying talking to you and solving LeetCode with you. Yeah, and have a nice evening or day. See you.